All right, let's get started here. So, for those of you just joining, welcome to Simplified Monitoring for AKS deployments with Logz.io. Just some quick housekeeping items. We'll be taking questions at the end of the webinar. Please feel free to ask in the chat room throughout the presentation. Additionally, we'll be sending out the recording by the end of the week. So again, welcome everybody. My name is Charlie Klein. I'm a product marketing manager at Logz.io. Joining us today is Paul Yuknowitz. Paul, I'll let you introduce yourself real quick.
Hey everybody, thanks for letting me join. I'm Paul Yuknovich. I'm one of the head product managers at Microsoft working on Azure development tools.
Great, thanks, Paul. So now let's get this started. I'll take you through a quick agenda. So first, we're going to explore the challenges of AKS monitoring. Paul will kind of walk you all through some common challenges he's been seeing for monitoring AKS deployments. Then we're going to look at some common open source monitoring solutions and why they can be difficult to implement. And then I'll give a Logz.io demo for how to better understand the telemetry data from your AKS deployments on Logz.io. And then we'll wrap things up with a Q&A. So without further ado, Paul.
Yeah, thanks, Charlie. Great. So what I want to do is just take the next several minutes and talk a lot about AKS and what it means to operate it and to monitor. So let's say if you're the operations team, you're the DevOps team, even the engineers, what are the jobs we're really trying to do to diagnose and monitor the system, and what are some of the key challenges? And then, I think Charlie's going to help us look a little bit at some of the solutions for that. So let's go next. When I think about monitoring, really the most key thing that I see people do is using metrics. Metrics are absolutely essential for really every aspect of monitoring, from the early identification phase, like knowing when something's wrong through alerts and through actions, but also when you're more specifically trying to understand what's wrong, the metrics even are critical for I'll call it the first phase of troubleshooting, the part where you're trying to identify and triage where something might be going wrong. So it's critical that every aspect of your system has great metrics flowing out, and I would think about it from the AKS Kubernetes cluster. I would think about it from the nodes and the containers running in your cluster. I would think about it from any of your application bits. So like thinking about your application, your runtime, the operating system that it's running in. You just want that really good metrics all the way through, because that's going to be the where you start. Now, as we say on the slide, the limitations with metrics is they'll tell you what is going wrong, but oftentimes they won't tell you why. And we look to other sources of data like logs, typically, to tell us why. And that brings up another challenge, which is correlating metrics and the associated logs so that you can dig deeper. That itself is a challenge, and we're going to go into some techniques to solve that a little bit later. I think one other thing that I'm seeing a lot with AKS customers and Kubernetes customers is, there might not be any one agreed upon way to collect and to ship metrics off of the system. So that's a challenge and a solution that we're going to keep in mind as we walk through this. So let's go next. Okay, so the next thing, once you've identified what an issue might be, just logs are absolutely essential at scale to dig in and learn more about why. What this will mean is, app developers are going to have to do a pretty good job logging, paying attention to health status, paying attention to errors, paying attention to warnings. And when errors happen, making sure that you have enough trace and enough logging to give you enough information to troubleshoot. And even, I think a best practice is to think about having some different log levels so that your app at scale can be running at a standard log level, which maybe is focused on errors only, and then having the ability to turn on a deeper debug log level as needed. And once you have, let's picture we've got a cluster of Kubernetes with a number of services and applications running on it. We have a lot of log data, but now you start to face the reverse of the problem, where you might have, what we think of as overtracing, or basically just way too many logs, right? And then it does look like finding a needle in a haystack, or as the classic new term is, finding a needle in a haystack of haystacks. So at this point, searching, indexing, correlation, and focusing in on the region that really matters is absolutely essential. And being able to quickly, from a top-down kind of a way, be able to zoom into the logs you care about. So that's it. And with Kubernetes, that's just kind of exacerbated because you're running in a cluster environment where there's just so many nodes sending logs at scale. All right, so we'll go next. So let's think about a solution that we guide people to do a bit. And I'll talk about the application, the Azure point of view, and I'm hoping Charlie can lend his expertise on the Logz.io side. So what we recommend is on the Azure side that we leverage Azure monitoring, and we ensure that the diagnostics settings for every Azure resource. So let's think about our Azure Kubernetes service or AKS service. Let's think about the networking that we're using. Let's think about the VM nodes that everything's running on, and then any additional data services that you might have. Let's say, Cosmos DB, SQL, Postgres, Mongo, messaging, service bus. We want the diagnostic settings turned on for all of those so that those resources are emitting metrics and logs. And a really cool thing is we have a mechanism that all of those Azure monitoring metrics and log streams have the ability to stream out through our Event Hub service. And that's an event streaming service that a number of other systems can basically subscribe to and glob onto. And that is a key way that we can send our metrics and logs to Elasticsearch and to Grafana, which are managed by Logz.io. The other thing is thinking about your application, and I'm guessing a number of you might already be running ELK, and so this is probably something that we're already doing. But in this case, inside of our application nodes, we would use things like beats, right? So file beats, metrics beats, or we could use an aggregated shipper, something like FluentD, FluentBit, and we're going to pipe our metrics, logs, and log files to those beats, and those beats can forward on at scale to Logz.io. And Charlie, what would you like to add on this architecture?
Yeah, sure. So I would just add that as far as configuring your beats goes, really the only difference that you would add is just adding in your Logz.io account token. That's all you need to do to specify where exactly you're going to send the data, and then our logs listeners will be able to identify that, and your logs will just and metrics will just pop up in your account right after you configure your beats, just that one time.
Yeah, that's a really good point. So you're probably already using your favorite ecosystem tools for Kubernetes and for, let's say, the ELK stack to ship metrics and logs. So that can absolutely stay the same. As Charlie's saying, you just configure to point to a different endpoint and authenticate. And then the additional layer in the cloud with AKS is just to really light up the Azure monitoring side by, again, going to the diagnostic settings, configuring the stream to an event hub, and then it's really cool because Logz.io has this function that they provide, and the function brokers between the event hub and the Logz.io endpoint. Great. I think, Charlie, do you want to walk us through this one?
I'd be happy to, yeah. So, like when you ask an engineer to start monitoring their Azure environment, they're likely going to turn towards the open source community, right? Just like they turn to the open source community for a number of other solutions. We've found that 85% of DevOps teams prefer open source monitoring tools. So it's really not even close. However, the only problem is that building and maintaining your open source logging pipeline can be really difficult at scale, especially at scale on scalable AKS clusters. That's, as Paul was mentioning earlier, can just produce loads and loads of data. So this requires a lot of engineering time, requires engineering expertise. And even with that, it can be risky. Your ELK stack or Grafana, two popular open source monitoring tools, those can go down if you're not scaling them appropriately. So it can be a bit risky. And it can even if they are up and running, it can still be difficult to really quickly identify and investigate issues, at the speed that might be necessary to, fix a problem before a customer has any negative experiences. So, what we hear is, I'd rather be coding, right? Rather than maintaining the ELK stack, Grafana, any other open source monitoring tool you're using. Engineers would rather be, delivering value for the customers, innovating, coding on what they were hired to do rather than, maintaining their monitoring solution at scale. And so that brings us to Logz.io. So this is an observability platform we just launched. We just recently announced the introduction of our infrastructure monitoring tool, which delivers Grafana as a fully managed service. So now we can monitor both logs and metrics. And this is kind of just an overview of what the logging and metrics data pipeline looks like. So if you see over on the left, you see the data sources coming from Azure. You have logs, metrics, traces, security sources, all unstructured data. And when you send that to Logz.io, which is kind of in this managed service box here, you can see that it starts in the data ingestion engine, which integrates with hundreds of data sources, many of them right out of the box, can process data at cloud scale, where it's then moved to our machine data lake, and that's basically where the data is indexed and stored by Elasticsearch. It's built to have very resilient indexing. The data parsing is automatic, but you can customize it however you might want if you want to, queries for customized logs. And second, and lastly, we have, you can automatically archive logs so that to put them in cold storage in a blob if you want to, run that log and metric data through Logz.io at a later time. So from there, the log and metric data can then be analyzed on. So we deliver Kibana and Grafana, which are the most popular telemetry data analytics solutions out there. But we also kind of built these additional advanced analytical capabilities on top of Kibana and Grafana just to make them faster, easier to use, more integrated, just a better overall user experience. And so that includes log and metric correlation, which we'll get to, AI-powered anomaly detection, which we'll get to, deployment tracking, alerting. We'll get to all that, explain further what that means. And then again, you're viewing all that data on Kibana and Grafana. We also have a cloud SIM, just because Kibana is so good at displaying events and investigating those events. We figured that'd be a great opportunity for to build a cloud SIM solution as well. We won't get into that today, but we have plenty of resources on our website to learn more about that. And then finally, we're working on a tracing solution, which will deliver Jaeger as a service. Like the ELK stack and Grafana, Jaeger is the most popular tracing solution for APM out there. And we're going to deliver it as a fully managed service to just kind of have the best open source tools for the job, running all at scale. So you don't have to worry about scaling the open source. You can just use it with these additional analytical features. All right, so at this point, I'd like to move into the demo. Let me bring that up real quick. All right, here we are. So there are two ways. So this is the Kibana screen. This is the home screen that you see when you open up Logz.io. This shows us all the logs generated by service 10 here in the last 2 days. But first, I want to show you all our new metrics monitoring solution on Grafana. So there are two ways I'm going to show how Logz.io can help you monitor and to identify issues and then troubleshoot those issues. The first way is starting with metrics and then metrics to identify the issue and then investigating the issue with logs. So here we see a number of pre-built dashboards. We're gonna open up the Kubernetes cluster dashboard, which is gonna show us some of our AKS data. And so these are all pre-built dashboards, but they're all completely customizable from here. You can see we have filters up here to bring up specific data. You can edit these panels just right here, and then you can add a new panel by clicking up here. But we won't go into that today. So if we scroll through here, these are, again, pre-built, just general metrics that most people would want to monitor for. If we scroll down here, one thing that immediately pops out is this Nginx container. Oh, looks like other people are on the demo account. Sometimes that'll happen, so I'm just going to reload that. All right. So one thing that immediately stands out is this Nginx container. It's spiking in CPU usage and memory usage down here. So that's clearly indicative of some kind of production issue. So we're going to filter for that. I'm going to click on this Nginx pod here and Nginx pod here. So metrics are great for showing that there's some kind of problem, as Paul was saying before. But we don't know what's causing the problem, right? There could be a million different reasons why this Nginx container is spiking in memory usage and CPU usage. So to diagnose the problem, to figure out what's really going on, we need to explore this issue in Kibana, which is going to show us the logs associated with that spike in CPU usage and memory usage. And so what it's going to do is apply the same filters from Grafana, including the cluster, the namespace, the service, and the pod name, to our logs in Kibana. So this shows us the exact logs that are describing the spike in data we saw in the metrics. So it's immediately clear that it's this Java stack trace exception that's causing the spike that we saw over here. So kind of with that, you can see how quickly and easy it is to drill down to quickly identify the root cause of the issue once you identify it in the metrics. And these logs would be, very difficult to find without narrowing them down from the metrics. As you saw earlier, we were looking at about 2 million logs earlier. It'd be very difficult to find this Java stack trace exception without narrowing them down from the metrics. So the next bit of information we might want to learn about this Java stack trace exception is what's the exact code that's causing this issue to happen. So what is the origin of this Java exception? To do that, we're going to go to this Insights tab up here. So what this graph does is it basically helps us correlate specific issues with specific deployments. So we can see which deployment caused certain issues. If we scroll down here, we can see this is the same Java exception we were just looking at. It's already plotted in the graph. You can see it's represented by this blue dot up here, or excuse me, this green dot. So it's been happening, 180 times. It's happened a couple of times now, so it's clearly some kind of issue. We're gonna zoom in just like that, and we can see that this Java exception wasn't happening before this deployment here. So these gray lines, gray boxes indicate deployments, and we can see that, we can say with reasonable confidence that this exception was caused by this deployment because it wasn't happening before this deployment. So this is kind of how we close the loop with our engineers and say, hey, you have this, it looks like this deployment reverting public certificate on December 4th caused this Java IO exception, please go back and revisit that. Again, it's giving engineers more context around the issue rather than just saying, there is an issue. We can say, here's the root cause of the issue, and here's where it's coming from. So I hope that all made sense. That's kind of the first way I wanted to show how Logz.io can help identify and troubleshoot AKS production issues. Again, starting with metrics and then drilling down into the logs. The second way I want to show how Logz.io can help identify production issues is just by staying in the logs. So we're not even going to go to the metrics product here. I'm going to clear these filters, and I'll show you how Logz.io can just identify logs indicative of larger production issues. So I'm going to filter for service 10. Service 10 is just a made-up service for the purpose of this demo. You can see if you've worked in Kibana before, this is all the same functionality that you would get in vanilla Grafana. I'll show you the additional features we've built on top of it just to make it faster and easier to use. So here we can see service 10 has generated about 1.7 million logs in the last 2 days. So to find an issue, we're not going to get anywhere by scrolling through this list, right? That's an unreasonable thing to take on. So what we're going to do is go to this patterns tab, and what patterns does is it clusters similar logs together so that we're looking at smaller groups of logs rather than 1.7 million logs all in a list. So what we can see is what kind of log data was generated by service 10 without actually going through every single log. So this helps us quickly identify the logs that are most interesting to us. So here we can see that 22% of the logs are just proxy request logs. That's not interesting to us. We can quickly filter that out. And we can keep doing that to continuously refine our search. And so if we keep scrolling down here we find something interesting, right? So this is an SSL library error. This is something worth investigating. So I'm going to filter that in. So you can see how quickly we filtered from 1.7 million logs to 4, right? Just like that, we have identified this SSL library error, which we can dig into deeper. And so we open it up, we can see the table, we can see the JSON file. And lastly, it was flagged as a cognitive insight. So what cognitive insights does is it uses artificial intelligence to cross-reference all of our logs with online discussion forums, such as Stack Overflow, GitHub, Bugzilla, Spiknix, and a number of other sources. And this helps us identify the critical logs in your environment. So this is our way of finding the needle in the haystack, identifying those anomalies so that you can find the most important logs right away. This can help you identify these issues. So here you can see that we matched this log string right here with all these discussions. If we open one up, we can see this same log was discussed here. We can see how other engineers fix the issue. Additionally, we can create an alert so that we can stay alerted if this error happens again. So I name it up here. I add the query right here to identify so we can narrow it down to the right source of data. We can say trigger if this happens, and then notify me via Slack, via email, via PagerDuty, however we want to do it. And then we can save it up here. So you can see all of our saved alerts already right here. And then just like we did before, we can correlate that SSL error on our insights tab in the exact same way we did before. So I'm just gonna plot it real quick. And again, we can see that SSL error pops up right here. We can say, oh, it's this updating Puppet certificate deployment that led to this SSL error to again, close the loop with developers. So those are the two ways that we can identify issues in the AKS environment and troubleshoot them and investigate them and correlate them with specific deployments so engineers know where to go for the origin of the issue. The last thing I want to show is just to elaborate on that integration, that integration slide that Paul was showing us earlier, to show how to ship log data into, or Azure AKS data into Logz.io. If we go into the log shipping page, scroll down to Azure right here, open up Event Hub. That brings up this page here, which is just instructions on getting data from Event Hub to Logz.io. If we just click this button right here, that automatically creates a template for us, which creates an event hub, as well as a blob and an Azure function. So if I fill all this out here, including my Logz.io token, and press purchase, it'll create those three entities which work together to ship data over to Logz.io. So the Event Hub collects the data, the Azure function forwards the data to Logz.io every set number of seconds, and then you can also automatically archive the data into a blob if you prefer. To make sure that it all worked and that the data successfully made it to Logz.io, a good way to check is just in our live tail. Just hit play right here, and it'll start showing you just in real time all the logs that are making it from your AKS deployment to Logz.io. It's kind of mesmerizing just to watch that. And that's it. So I hope everybody learned something new today. I'm going to open up these questions in the chat window. And it looks like there are no questions. So if you have any, feel free to ask. I'll keep it open for just a bit longer to add your questions to the chat window or the questions window. But if there are none, then have a great rest of your day. I hope everyone learned something new. We'll send the recording of this webinar to you all, and it'll always be available on our website. Paul, thanks so much for joining.
Hey, yeah, thank you very much.
And again, I'll keep it open for about 30 more seconds, maybe a minute. And if there are no questions, then I'll end the session. Okay, now I got some popping in. All right, so the first one, for the cognitive insights, are those just an automated Google search for the error, or are they curated in some way? Yeah, so great question. So what Cognitive Insights is doing is it's using AI to actually crawl the web to correlate log messages in our environment with these online discussion forums. So it's not so much that they're curated, it's that they're picked right off of discussion forums from the web by cross-referencing the log message itself with what's being discussed on these discussion forums. So I hope that answered the question. Another one. Hi, can you share how you configure the Elastic Stack to the Azure components? Sure. So I think what this question is getting at is, how did you configure the Elastic Stack?
Yeah, I think, do you have access to a portal you could show right now in Azure?
I can certainly try. Yeah, here we are.
Okay, great. So like if you search for, do you have a Kubernetes cluster handy? AKS cluster?
You know what, it's not coming, I do not, I wish I did. It's not coming from this account. It's coming from a separate account, so I can't show that right now.
Okay. If there's another quick question, we can come back to it, and I'm gonna get my screen ready.
Okay. I'm reading one right now, trying to decipher it. You may point to something. Yes. So one of the questions is if one of the insights is basically not accurate or not suitable or just unhelpful, is there a way to let us know of a potential problem with the insight recommended? Yeah, that's a really good question. So I will show you how we make that, how we help you provide feedback on the insights. Let's see. Oh, this brings us here. It looks like this one doesn't, I think it depends on the insights. With some cognitive insights, you'll see a happy face and a smiley face, and you can just click on the, or excuse me, a happy face and a frowning face, and you can just click on the frowning face if there is, if the insight isn't relevant to you or isn't important. I think this one has gotten enough smiley faces so that that option is taken away. It was confirmed as a legitimate insight. However, if some of the insights aren't used as much, you have the option to click on a frowny face to indicate that the insight wasn't helpful to you or wasn't relevant. So the answer is usually, but not always.
Charlie, would it be okay if I just share my screen for a second? I can answer that past question on configuring.
Absolutely. Okay. Let me do that real quick. All right, Paul, do you have the ability to share your screen from here?
You can make me a presenter. That would work.
I'm looking for you here. I'm not seeing you as a potential presenter.
Yeah.
Let me.
That's okay. I probably didn't. I probably don't have the right link for that. Well, let me I guess talk you through it. Actually, could you share your screen again? And even though you don't have an AKS, we'll just talk through it.
Sure.
We'll get really close. Okay, great. So if you're in the portal, once you have an AKS cluster, so we can bounce out of this, and we'll go to the portal menu on the right-hand side corner, that hamburger control. Do you know what's called hamburger control? And then we'll go to the monitor. About 2/3 of the way down, it says monitor. And so all things Azure monitoring are here. And one thing I like to say is you're not choosing Logz.io versus Azure Monitor. Actually, you're using both because that's Azure Monitor is how we get the data on the Azure side, right? So if you scroll down the left-hand side in the monitor blade, you're going to see these diagnostic settings. So if you click that, please. Now, every service or resource in Azure, actually, you've got a Kubernetes right there, has these diagnostic settings. And so if you picked the Azure Logs Demo Cube, and then we'll go kind of far, but we won't commit it. So we'll say add diagnostic setting. All right. And what you're seeing here, if you scroll down, these are all the log types intrinsic to AKS, and then also the metrics, just called all metrics. But that's all the scalar single dimensional metrics coming from the cluster. So what you would do is you'd pick the logs and metrics or all of them, And then we would check the box to stream to an event hub. You can just try that, stream to an event hub, check. And here you would configure the event hub. Charlie showed that you can click that button to create a function in an event hub. So after you've done that step, you would simply pick the event hub that was created as a result of that. And now basically Azure Monitor is streaming in real time metrics and logs to the event hub, which is like think of that as like a message bus, which is pub sub. And then the Logz.io endpoints are listening to that event hub via the function, and basically the metrics and logs will stream in. But mechanically, this is exactly where you go. You go to Monitor, Diagnostic Settings, you pick all the resources that should participate in Diagnostics Export, you stream it to the Event Hub, and you are golden. And streaming to the Event Hub doesn't preclude you from also streaming to anywhere else, like a storage account. So you can stream it to multiple places. Hopefully that answered your question.
Thanks, Paul. Next question is, please share at a high level how you're running the ELK stack in Azure. Yeah, so we have, I mean, on your end, on the user's end, you don't even need to think about running the ELK stack anywhere, because we run the entire thing as a fully managed service. So you just ship us your log data and metric data, and we will run it through the entire logging pipeline for you. All you do is configure the log shippers and metric shippers, and then interact with the data however you want on Kibana or Grafana. Logz.io users do not need to worry about running the ELK stack at all.
Is it okay if I geek out a little bit?
Please geek out, Paul. Thank you.
Okay, great. So, I mean, Charlie's answer is the right answer, which is, hey, it's a managed service. Don't even worry about it. Like, we'll take care of it. But yeah, let's geek out a little bit. My team worked with the Logz.io team as this was being stood up, and essentially there's a true Elastic Stack cluster that is stood up, like thinking about the exact open source version, the real open source version that we all have built from source. And that stood up to have a durable cluster so that there's enough data and view nodes to handle the cluster at scale. And then there's additional layers that kind of expose authentication so that it works with Azure and Active Directory and some of the key things we have there. And then it's deployed into data centers in Azure. So we have at least about 10 data centers or regions in Azure where Logz.io can be used. So like those are physical deployments, and I believe even the team uses Terraform. So it uses Terraform to stand up the regions. And so it's similar to how I think any of you might be operating an ELK stack today. It's just operated as a managed service with multiple tenants and with a front end portal in front of it, stood up on Azure data centers. And because they're in Azure data centers, your application in the data center and the Logz.io endpoint are co-located, so you're not egressing out of the data center, which is really handy. And that's essentially it. I mean, hopefully that answers. So it's very similar to how you would do it, but it's operated like a SaaS product. Right.
Thank you, Paul, for elaborating. Next question. Do we need only a daemon set to push Kubernetes logs? The answer is yes. And there are multiple ways to do it, but a lot of our customers use a daemon set to push Kubernetes logs.
And I think like a subtlety of that question, which I like, is, hey, do I need to go and like change every container image? And no, because you're using the daemon set as you're pointing out. So that's a really good observation.
And if I go to log shipping here, we have instructions for how to do it specifically with Logz.io right here. And it'll show us how to configure the Fluency daemon set. It's pretty easy. All right, next question. Could you please show how through the metrics you can pinpoint the associated backend logs which are responsible for the issue in the infrastructure? Yes, I can. So if we go back to this metrics dashboard here, we can see that this Nginx pod is spiking in CPU and memory usage. So I'm going to filter for that pod. So these are the metrics in Grafana, and now I'm going to identify the associated logs that are responsible for, or rather describe this issue by exploring them in Kibana. So that's a quick integration there. Just click on that button and it'll automatically show me the logs that describe the issue we saw in Grafana. Oh, looks like there we go.
And just to indulge a little bit, because we're getting really good technical questions, the correlation IDs or vectors being used here, you could even see it in the query. So there's things like the cluster, the namespace, and the service, and then obviously a time range. So when I think about monitoring, logical applications or deployment units are oftentimes in namespaces, and then services give you a logical unit over pods and replica sets that belong to a particular service. And so those are all passed in as parameters, from metrics to logs here.
Yeah, thanks, Paul. Last question. How do the Logz.io endpoints need to be configured to the Azure Event Hub listeners? Let me try to decipher this question. I think the question is if the Logz.io listeners need to be configured to receive data from Azure. I believe that's what's being asked here. Yeah. And the answer is you do not need to configure anything in Logz.io to get the data from Azure to Logz.io. All you need to do is insert your Logz.io account token, and our listeners will identify that, and that'll send it to, that'll send the data to our listeners, which will identify your account and make sure that the data ends up in your account.
There might be one more subtlety to this. So, if you're familiar with like Logstash or Beats, usually on the ingress side, we're also thinking about formatting the data a little bit, so that if you take loosely structured data, you want it to kind of look useful from the Elasticsearch side. So the Logz.io team has already built a number of formatters that are native for Azure. So whether it's like activity log or Kubernetes, they've already sort of pre-formatted the data so that it's really easy to drop into Kibana dashboard or search, and it looks good. At the end of the day, it's just Elasticsearch, so you can totally customize how this works, but built in, you don't have to do any formatting. It's just like Charlie said, we've already kind of made sure that the data types from Azure are understood.
Right. All right, thanks everyone. That is all the questions. Thanks so much for joining. You expect to receive an email from us shortly with the recording of the demo. Paul, thanks again so much for attending. I'll talk to you soon. And take care, everybody. Thanks again.
Thanks. Bye.